Assalamualaikum warahmatullahi wabarakatuh. And first of all, for our project we choose solar power plant because it's more suitable to build in UTM. Solar energy can be converted into electrical energy by two different processes. First, photovoltaic conversion and thermodynamic cycle. Solar energy the most abundant source of energy on Earth and considered as an important alternative to fossil fuel. We choose solar power plant based on 6 criteria. First, location. Second, potential power plant. Operating hour. For safety, cooling and waste. For location, to build solar power plant, we choose the place is most exposed to sunlight, such as Padang Kawat UTM. For potential power plant, we supply to residential and around UTM. For operating hour, we design our power plant to operate 6 hours to produce or to store 100 megawatt per day. We produce a design by doing a research on power plant at India.
So for the next criteria is safety. How to ensure the safety in the power plant? So we must require all workers to have their safe workplace, and each of them must have OSHA license to work in our power plant. Okay, for the second criteria is the cooling system. How we want to make sure our power plant is still cool? We use a cooling tower. Where cooling tower is using water and air to cycle around our power plant, and it will generate also an airflow. Okay, last but not least, the waste material. How we want to expose the waste is we recycle the waste using the sunlight bag. We will use the plasma, the infrared or what to dispose the waste material in the power plant itself. That's all.
That is sun that give the UV light to the solar panel and go the steam plant to the turbine. The turbine steam flow at a high pressure around the wheel here, like a windmill metal blades. The design the steam flow pass and known as steam turbine. This device is designed to convert the steam energy into the kinetic energy. That is a moving blade that will convert to the kinetic energy. For the turbine to work efficiency, heat must enter the really high temperature pressure and lift at as low pressure as possible. So this turbine will go to the condenser and will go to the cooling tower. So the giant jug-shaped cooling towers you see the old power plants make the turbine more efficient. Boiling hot water from the steam turbine is cooled in the heat exchanger called condenser. This is condenser. So from this condenser will make a Rankine cycle to the cycle to the pump. The turbine is linked by an axle of the generator. So the generator is spin around with the turbine blades. As it spins, the generator uses the kinetic energy from the turbine to make the electricity. So the electricity will spread to the electricity tower, the city or the factory or all over the residency. Okay, this is a simple schematic diagram. This is a solar panel and go to the turbine, generator to the resources, and the 4 is to go to the condenser, a cooling tower, pump, and back to the solar panel. This is a simple Rankine cycle as we learned before. Okay. Alright, from this we get the TS diagram. So the TS diagram will show you the process 1, 2, 2, 3, 3, 4, and 4, 1. We must find the H3, H4, H2, and H1. So we must calculate one by one. So first of all, we must calculate the H3. So the H3 is P3 is given and T3 is given. So the T3 is greater than T sat, so it is superheated. So from the superheated table, we could not get H3 immediately. So we must do the interpolation table to get the H3. So we know that T4 is lower than T sat, so it is mixture. So how we want to find H4? By using this equation, H4, HF, and X4, HFG from the table we could get, but we do not know what is X4. But now we know that S3 equals to S4 because the TS diagram show that T3 and 4 is isentropically processed, so it's same. Now we know that S4 is 6.2. From this equation by self, we can get by using the interpolation table, and we get S4 SFG. So we fill into the formula here, and we can get X4 equals to 0.791. Formula, we must find HF and HFG by using also the interpolation. So now from the interpolation table, get HF equals to 381 and HFG 2294.02, and fill in the formula and we get H4. So now there's H1, whereas it is a saturated liquid process, so H1 equals to HF. From the H1 process, we know that T1 equals to 80 degrees Celsius and P1 equals to P4, there is 60 kilopascal. So there is no HF in this table, so we must do again the interpolation by using this interpolation table, and we get H1. Compressed liquid, there's another method we can find by using this. H2 equals to H1 equals to W pump and equals to VF P2 minus P1. We know that VF is very small, so we assume that the value of VF is 0.001, and key in the formula, we know that H1, we know the P2, and we know the P1, and we fill in the formula and we get H2 42.1. So this is how we want to calculate the work pump, H3 minus H1 from the calculation before, and we get the work pump and the work turbine, H3 minus H4. From the calculation before, we get the work turbine and Q in, H3 minus H1, 37, and we get the work in and the Q out, H1 minus H4, and we get negative 1.7706. Okay, now there is how we want to find the efficiency. From the efficiency, the formula is work turbine minus work pump over Q in. So, I'm sorry, 100. Alright, so work turbine we calculated before, and work pump, and this is Q in, and we get 38.06%.